Hi listeners, Benjamin here. Welcome to the Friday edition of the Nature Podcast. It's the briefing show where we talk about a couple of stories from the Nature Briefing. Joining me this week is Lizzie Gibney. Lizzie, how are you doing today?
Hello, Ben. I am good, thank you.
Well, first story this week. It's a sad story on the face of it, of course. The world lost an icon this week with the death of Dolly Parton, who I think it's fair to say universally loved across the board. And perhaps not the most obvious choice to talk about on the Nature Podcast. But Lizzie, you've been diving in to the scientific aspect to her life, I suppose.
Yes. So when this news came through, I don't know what it was like for you, but all of my WhatsApp chats lit up. Like everybody seems to have loved Dolly Parton from all walks of life and in all ways. And then I found myself in this quite unique situation of writing a story about her and her connections with science, which are maybe not obvious, a country and western singer from Tennessee who is known for all kinds of things, for her incredible warmth and personality and kind of welcoming of everybody on this planet. But she really had an impact on science, as sad as it was to see her pass. Like, it was a wonderful thing to be able to celebrate the impact that she has had.
Well, let's go through a few of these things then. I think we have to start with the COVID vaccines. And she was a face of the vaccination drive, but also she was behind the scenes as well.
That's right. So it stems actually from, she had a friendship with a clinician at the Vanderbilt University Medical Center in Tennessee. She was from Tennessee. And in talking to this researcher, she asked right at the beginning of the pandemic in March 2020, is there anything that I can do? And he said, well, we could do with some money. And so she gave $1 million in March 2020 to the Vanderbilt University Medical Center. And they used it to create this COVID-19 research fund, the Dolly Parton Research Fund. And at the time, they were working with a whole group of different researchers, including Moderna, the biotech firm, to develop one of the first mRNA vaccines, for COVID. And so actually, researchers at Vanderbilt said that this money was really critical for that early stage of research in getting this off the ground back in the early days of the pandemic. And we did a little bit of digging into the actual research papers that stem from that and found 37 different papers that cite this fund as supporting their work. So 37 different papers were in part produced through this money, and certainly it helped to spur the actual creation of the vaccine.
And she took a shot of one of these vaccines live on air, right?
Yeah, she kind of filmed herself and then uploaded it onto a few sites. And what a wonderful thing to do, because I think she crossed the divide so much and she was seen as of the people. She was really a great person to be out there as an advocate. And her candor and this kind of joy that she brings to everything, she brought to that as well. So she had a little cutout bit in the top that she was wearing so that the needle could just go straight in without having to roll her sleeve up. It was a genius kind of fashion choice. She talked through why it was such a good idea. She reworked her famous track Jolene to be a vaccine. So bringing down people's levels of worry, I suppose, because there were people concerned about this. It's quite, an experimental vaccine back then. It's very hard to say if she affected, how much people actually ended up taking the vaccine. But you could imagine that somebody like that is going to put people's minds at ease about it.
Yes, and it's worth going back to watch the video of that occasion because it is absolutely spectacular, wonderful. But it's not just vaccines and vaccination. She did a lot of philanthropic work for science as well.
Yeah, she played a big role in public health. A comment that a lot of people made was that she chose not to be super rich. She gave, I don't think we have a figure on it, but she gave an awful lot of her money away. She came from very humble origins and obviously became this superstar and earned huge amounts of money. But all the way through her career, she gave, pots of million here and there to lots and lots of different causes, to paediatric infectious disease, to paediatric cancer care, to women's centres. There are different hospital departments that are named after her. She also contributed a track to a charity album that was raising money to fight HIV/AIDS. And in fact, it wasn't just public health, but literacy. So she created the Dolly Parton Imagination Library, which as a parent myself, I think this is just such a wonderful idea. What the Imagination Library does is delivers a book every month to kids between 0 and 5, before they go to school in the US. And I think 1 in 6 kids in the US get those books from the library. And the organisation themselves has done some studies on that and found that it really does help to boost engagement, with reading, literacy rates, the amount of time that parents spend reading with their kids, like all those things that we know are super important foundations. So what a phenomenal thing to do. And it's been taken on. It's not just the library, it's kind of a public-private partnership. So there is some public money going into it. But it's been something that I would say has really changed a lot of everyday lives in the US.
And a few weeks ago, me and Flora were on the briefing chat talking about Dolly the sheep, obviously the first cloned mammal, a huge moment in science. But her name, Dolly the sheep, maybe gives a little insight into who she was named after.
Not a lot of people know that Dolly the sheep was named after Dolly Parton. Now, the reason why is not the best one, I would say. It's probably a case of male scientists thinking this was funny at the time, but Dolly the sheep was cloned from a mammary cell, breast tissue cell. And Dolly Parton's breasts were well known. Now, something she talked about a lot, to be fair, also. So Dolly the sheep was named after Dolly Parton for that reason. And of course, it's something that, some people may interpret as even being disrespectful. But I do think they were trying to celebrate her in some way. And actually, she was incredibly gracious in that when asked about this fact a few years ago, she said that she was flattered by having Dolly named after her and went on actually to say that she didn't want to be cloned, which is always good to have that in writing. But, this also wasn't the only time she's been an inspiration to scientists. So we had an eminent astronomer in the UK, Catherine Hamans, say that she acknowledged Dolly Parton in her PhD because just the music had carried her through. But actually, Dolly was the subject of a number of PhDs. I found maybe half a dozen different PhD theses about different aspects of her and her feminism, her support for LGBTQ communities, her femininity, and how she dealt with being this woman in a very kind of male country singing world. So she was the subject of study. Perhaps she even touched on physics, although this one's going to be extremely hard to prove. So in 1969, Richard Feynman, a very famous US physicist, came up with the idea of partons, which were the kind of subatomic particles that they thought existed within protons and neutrons. We now know that they're made up of quarks and gluons, but that wasn't known at the time, so they were just called partons. And Dolly was around already at the time. She was a rising star back in 1969, so there is some speculation that even these subatomic particles were named after her. But alas, that one is unproven.
And as someone who made a documentary about the naming of species, it would be remiss of me not to say that there are at least one, maybe I think a couple of species that are named in her honour as well. But yeah, clearly the word legend is bandied around often, but she absolutely was a legend, and her legacy will continue for many years to come.
Definitely. She seems to have had the most incredible heart. And maybe I can just wrap up by reading the very end of the letter that she sends to the graduates of the Imagination Library. So when they're 5 and they're about to go off to school, they all get an individual letter from Dolly. And it says, "There's no limit to what you can do or how far you can go. Just remember the lessons my family taught me. Dream big dreams, learn everything you can learn, and care for all those who care for you. You do all of these things and you can be anyone you want to be. You are terrific. And remember, I will always love you, Dolly."
Oh, bravo. Bravo.
Literally, I have tears. What a woman.
What a woman indeed. All right, well, listen, I'm not sure how I can follow that, but let's try.
How are you going to top this, Ben? What's your story?
Well, I have got a story that is actually weirdly tangentially related. And let's stick in the world of mRNA vaccines and the results of a promising trial for a cancer vaccine. And this is a story that I read about in Nature.
So cancer vaccine, what kind of cancer are we talking about?
So we're talking about melanoma in this instance. Now, I know we've obviously talked a lot about COVID mRNA vaccines there, and the pandemic really was a spur for these things to become front and centre for obvious reasons. But as a technology, the idea that mRNA vaccines could be used as a therapeutic for cancer actually predate the pandemic. They were really kind of the very early idea as to what these might be. And that's long been the hope, but evidence hasn't necessarily been there about their efficacy. Now, we've got some evidence that that might be the case, although there are some caveats. Now, specifically, we're talking about a cancer vaccine developed by Moderna and Merck, 2 pharmaceutical companies there. And as I say, it's shown promise, specifically in a phase 3 clinical trial the companies announced last week. Now, this is a sort of later stage trial where a large group of people receive a therapeutic to test it against the current best or the most available that's in use.
And can we go a step back? Can you remind me, as the kind of Dumbo physicist, like mRNA vaccines are exciting because you can tailor them in all these different ways to have a different target, and it's something we can do quite quickly, right? So how have we pivoted from, COVID and infectious disease to cancer?
Yeah, so quickly is one we can discuss in a bit, but certainly it can be very, very specific to a person. So in this instance, this vaccine is called intismeran, and what it and other future potential mRNA vaccines do is the researchers take a sample of a person's tumour and they sequence the DNA to look for mutations that have developed in said cancer cells. Now, these mutations mean that the cancer cell makes proteins on their surface that aren't supposed to be there, like little flags. You can imagine it at that. And if you can take the sequence that makes that flag and put it into a vaccine, essentially, and put that in someone, the immune system will recognise that flag, and then it will say, hang on a minute, this isn't supposed to be here, and then attack any potential cancer cells. Now, in this instance, this isn't a vaccine in the sense of preventing cancer. It's a vaccine in the sense of it's been tested on people who have had melanoma, had it excised, and the idea is that it hopefully prevents or delays it coming back.
Okay, so it gets the person's own immune system to rise up and attack these cancerous cells.
Essentially, yeah. And in this study, they have enrolled over 1,000 people with advanced melanoma, as I say, that's been surgically removed. Now, they either received this vaccine combined with an immunotherapy drug called pembrolizumab, and that's used to treat melanoma, or they just received this pembrolizumab alone. And this is where we need to be a little bit careful with the results here. The companies announced that people on the combined treatment survived for longer without recurrence than those did who only received the pembrolizumab. Now, these results haven't been peer-reviewed, they haven't been published. The devil's in the details here. They do say that they plan to present more detailed data at an upcoming medical conference, but I think we need to wait to see exactly what's going on here.
But that would be really promising if it is having an effect. And it sounds like cancer is really becoming an area where these mRNA vaccines are starting to show real potential, right? I've heard of a few different examples now.
Oh, 100%. There is an absolute list of different companies who are using different mRNA platforms to target different types of cancers, pancreatic, gastric, lung cancer, different ways of attacking melanoma, potentially. So yeah, it's long been hoped that this could be a thing. And obviously some of these drugs are in different stages of development. Some are still in phase 1 and phase 2, so early on in the clinical trials process. But this one is quite far through. But while it is potentially good news, and I think I'll underline potentially, there are obviously caveats to this as well. These drugs will need to be tested and people monitored for many years to establish whether the treatment extends their lifespan, how long it lasts for, this sort of thing. And of course, with this ultra-personalised medicine, it is a challenge, potentially for their widespread use, because you have to take a cancer sample.
Be expensive.
Expensive too. You have to sequence it. In the article, it says that each vaccine can take months to make. And obviously, in some cases, these people who need them could be in very poor shape and might not survive long enough to take them. So there is that to consider. But at Nature, we've been writing about mRNA cancer vaccines for a very, very long time. And it seems that maybe we're getting towards something. Obviously, we'll have to wait, and the devil is in the details.
Yeah, that sounds like potentially a source of hope. And the fact that we're even getting to these phase 3 trials now means, clearly a lot of work is coming to fruition. So yeah, I think probably time to leave it there with the briefing chat this week.
Yeah, I think that's right. Listeners, if you'd like to get in touch with us, you can. We're on email, podcast@nature.com, or you can reach out to us on social media @naturepodcast. It's a public holiday here in the UK, so our schedule is going to be slightly different next week, but keep an eye on your pod feed because there will be things going up. All that remains to be said is I've been Benjamin Thompson. Lizzie Gibney, thank you as always for being here.
Thank you so much, Ben.